Good day, everyone. So this is the first vectors review video for lab 1. Okay, so this is your first lab of physics 201. And the main idea with this lab and next week's lab is to do a review that aligns with what you are going to be doing in the lecture on the first week of classes, which is a review of vectors on the plane and also vectors in 3 dimensions. On the second lab, you're going to be doing coordinate systems, and it's mostly a mathematical review of vectors. So the idea of this video is to show you what you are expected to do and to show you where you will find the information in Canvas. Now, keep in mind that I'm recording this video while I'm still tweaking and cleaning the shell. It's still like mid-August, all right? So by the first day of classes, everything will be ready to go. Now, most of it, actually, it's there. So if I go to the Canvas, right now you will find this. It's not going to be the same. My information will be here. The schedule, the material will all be updated. There is no lab groups. Okay, I think it's easy if you submit this individually. I will activate discussions though, so you will see what that's about once the syllabus is uploaded. And I'm still gonna leave the exploration of physics in here, but you're gonna find that a lot of the labs will have 2 versions. So you have the online version and the exploration physics version. So you can use either of those for the Ohm's law, circuits, capacitors labs. So lab 1, you're gonna find all this. This is where you're gonna submit it in assignments. So you will go to assignments and you're going to submit your vectors lab data. That's gonna be your submission. So all this has to come out. We're not doing that yet. And then there's going to be individual questions. Okay. Now it's online, so you're not going to be doing an experiment in class, but you're going to be doing a few questions based on the experiment per se. So experiment 1, vector algebra. So we're going to start with a review of vectors. Now, there are 3 sections in here, or 3 procedures. The first one is very conceptual. It's asking you about scalar quantities, vector quantities. The second one is about vectors on the plane and unit vectors. And the third one is, and the third one, fourth one, sorry, 4 procedures, dot product and cross product. All of that will be covered in class. Now, don't worry because I'm going to go over these sections right now. So, for example, in section 1, you have list scalar quantities and vector quantities. You see, a scalar quantity is any quantity that has magnitude. So remember, a vector or vector quantity, right? Or a vector is a physical quantity that has magnitude and direction. So an example will be from physics 1. Displacement, right? When you guys did the vector R, right? You have vector R for position that, and then you have R1, and then you have here R2. You drew this to show you R2 minus R1, which you call delta R. This is the displacement. That's a vector. Okay, so that's a vector here, displacement. And then if you define displacement, you also define velocity, right? velocity here, velocity is also a vector. That is equal to delta R over delta T is the rate of change of position, right? In units of meters per second, if this is in meters. Of course. So that is basically, right? And then what will be scalar quantities? Scalar quantities, we could say speed and distance. Now they ask you for 5. I already gave you 2. Another one will be acceleration. Acceleration is also a vector. Okay. So then what could be another, right? Scalar, because for vectors we have displacement, velocity, acceleration. For scalars we have distance, speed. We can use energy. Energy is not a vector, it's a quantity, right? Energy, power. So there's examples in there. Okay, so take it as a review from Physics 1, all right? The geometric view of vectors and how to add vectors graphically. You see what I did here? This is a graphing subtraction, or also you can do the same for adding vectors. To add vectors or to visualize vectors, we normally use the X and Y plane. So for the next question, you have to explain and draw vectors on the plane. So you can just show something like this. X, Y, and then you can draw a vector like this. Vector A. Now, why do we use an arrow? Because it's telling us the direction, right? The magnitude of the vector is this. We also call it the modulus, right? That's the magnitude, and we label it with the, like the absolute value, because the magnitude is always positive. And this direction will be on the X and Y. Now, you can also say this is the north, south, east, and west. And if I add an angle of, say, 45, this is a vector A in the 45 northeast. Right? You can do it. You can also, and that's why we use vectors in physics, because it gives us information about the magnitude, but also the direction, always respect to the horizontal, by the way. Okay? Now, how do you add vectors graphically? Well, I can draw a vector here, say vector B, and to add them, we use a parallelogram method, right? Where, graphically, vectors can be moved parallel, keeping the same magnitude and the same direction, right? Here, so there. That's vector B. So A plus B will give you vector, let's say, C. Like that. Right? This new vector C is A plus B. So that's what I have to show for when they ask you to do it graphically. We're still not finding the components yet, as you probably remember from Physics 1. But this is something that you should have also learned in mechanics, right? Or in the vector class. So what happens then if you multiply a vector by a scalar? The magnitude increases. The direction is constant, but you can show in there what happens if you double the magnitude of a vector. 2 is a scalar, the vector is just a vector. So you're multiplying a scalar, or in this case, a number by a vector, you are changing the magnitude. Okay. Now let's go into part 2 and then part 3. They actually go together, sort of. Part 2 and part 3, you need the I, J's, and K. So what are those? So let's go back to the vectors on the plane still. And let's show you the components of a vector. You see, you can have on the X and Y plane. Right? You can have a vector. I'm going to give values now. So let's say you have a vector of 20 units at an angle of 30 degrees. We can break that vector into components. This 90, and we have this also 90 degrees. So you can find, you can find the X component and the Y component. Right? Let's say this vector A. So AX, AY. So AX is for this triangle here, 20 is the hypotenuse, AX for 30 is the adjacent. So it would be 20 cosine 30. And A1 is 20 sine 30. Now, you want to use a calculator, but I always tell that at this level, you guys should know your spatial triangle 30, 90, 60. Right? For that triangle, if this is like K, this is like 2K, this is like K root 3. That's the relationship between the sides. So cosine 30 is adjacent over hypotenuse, so root 3 divided by 2. So 20 times root 3 divided by 2, that's 10 root 3. And sine 30 is opposite over hypotenuse, 1 over 2, that's 20 multiplied by 1 over 2, that's 10. So we have X and Y. So you can say that vector A, vector is the X component, 10 root 3 in the I direction plus 10 in the J direction. So, okay, what is this I and J? I and J are the unit vectors. You see, for the X, we have the I direction like that. And for Y, we have the J. And I draw that little arrow to show you that unity. Right? That means that the magnitude of I is 1. Okay? Those are just directions of the X and Y plane. Now, if you include the Z-axis, right? If you include the third dimension, that would be your K. So I can write here that let's write here, the X, Y, Z, yep, X, Y, Z are basically your I, J, K. And you can find, you're gonna find in this course, electric fields, magnetic fields in 3 dimensions. Okay? So that's basically what you have to do for that section, right? Now let's see what else do they ask you. Breaking the components, vector. Okay, so how do you write any vector into components? And then let's do like a sum and subtraction. So any vector, like for example, this can be written in a coordinate form, right? Let's actually do it by moving this. Let's see. Maybe I can do this. I think, right? Let's just erase this for now. And let's show you a vector sum. I mean, it's something that you probably have done in algebra or pre-calculus. Like when you have negative 5 comma a, that's negative 5i plus 8j. That's what you have to do. All right, 5. All right, so then how do you add? If vector A is saying 9j, cuando is commutative, all right, minus I, and vector B is 6I plus 3j. How do you add this? It's easy. Very easy, guys. J's with J's, I's with I's. And if I want to find the magnitude of this, the magnitude is the square root of the x component plus the y component square. The Pythagorean theorem. So a square root of 25 plus 144, which is the square root of 169, which is equal to 13. All right, so that's pretty much. I mean, I'm sure this is going to be more like a review. All right, those individual questions where you have to be more careful. And the dot product and cross product, all right, how do you, like here they ask you for a geometric view. The geometric view for a dot product, guys, normally I use, you can find it on the textbook, but the way we think about the dot product is by projections. So you have a vector A and a vector B at some angle theta, and you're trying to project this vector here. So A cosine okay, so you can visualize dot product like that. So you have a cosine in there. All right. This one, I want to show you using the dot product using the vector components. All right. The magnitude of the vectors we already went through on that. But let's say you're giving a vector A. 2i plus j and vector B negative 5i plus 3j. How do you do the dot product of these vectors? And then you see that we can use this to find the angle theta. That's the idea with the dot product, is to find the angle between vectors. A dot B, that's the dot product, is defined as magnitude of A times magnitude of B times the cosine of the angle in between. Cosine there. So if I multiply A cosine times the magnitude of B, I get that. So that is why I told you the idea behind dot product is like a projection of one on the other, and then you multiply them when they are the same dimension. So what's the alternate way if I have it like this? A dot B, if you write 2i plus j dot negative 5i plus 3j. You kind of do like a sum. You do i's with i's. So 2 times negative 5 is negative 10. I times I is 1 because the magnitude of I is 1. Scalar. And then 1j times 3j plus 3. Negative 10 plus 3, negative 7. So this is the thing about dot product. A dot product is also called the scalar product. In Spanish, we call it producto escalar. Why? Because the answer is scalar. That value there is scalar. Right? So you can use this to find the angle between vectors. Because you see, I have A dot B. Right? This is A dot B. So I have this. This is negative 7. And I can find the magnitude of A. So let's do that exercise because you have to do that in the lab as well. All right. So let's erase this. And let's use the definition of dot product. Dot product. Okay. So 2ij negative 7 magnitude of A is the square root of 2 squared for 1 squared 1, so square root of 5 multiplied by the square root of 5 squared, negative 5 squared is 25, 3 squared is 9, 25 plus 3 is 34 times the cosine of the angle. So cosine of the angle is negative 7 divided by the square root of 5 times 34, which is 170. So what I do now is I have to go to the calculator and do the cosine inverse. You guys are gonna have graphing with you, but pretty much you just have to do the trigonometric inverse. Let me just say here. Okay, let's do it step by step here. Square root of 17, negative 7. Okay, it's good. 17, all right. Trigonometric second inverse cosine. Okay, so I'll share my screen so you can see what I got. Like 122.5 degrees. So the angle theta is about 122.6. Okay, so what does this mean? This means that the angle between the two vectors was an obtuse angle, like this. You can see with this, 2i plus j, 2ij will be around here. And vector b is negative 5 plus 3, yeah. Anyway, so that's the angle. Because it's on the plane, because it's on the plane, you can visualize the vectors here. So that's what you have to do in part 3. That's dot product. All right. Don't worry because I'm pretty sure in the lecture I also want to go over this. This should help you. And then the vector product, right? The cross product. That one is a little bit different. In the cross product, the answer is a vector. And the procedure is a bit different. It's more mathematical. So let's go over that. Let's see what they ask here. how is the cross product calculated? Guys, there are two ways you can think about this. You can think about this in terms of X cross Y give you Z. That's called the right-hand rule. All right, like this. All right, that's how you find the third dimension using your right-hand rule, your thumb, right? Like that. What is the cross product between Cartesian unit vectors? So I cross J will give you K. And you can prove that using matrices and determinants. That's what you have to do in question 5, 6, and even 4. What's the algebraic view and how to find the cross product between vectors? And now they're going to give you vectors in the space. There is, can you find a vector, that dot product of vectors in a plane? Yes, but we normally use this method more for vectors in space. So how do you find the cross product of vectors in space? Well, let's show you the procedure because you're also going to need that for the individual questions. Okay. So for the cross product, let's give you vector A equals to 3, 1, -2, and vector B, -4, 0, 8. So the first step will be to write those vectors in A, J, K. So I will write them like 3i plus j minus 2k, and this one will be minus 4i plus 0j plus 8k. So A cross B is the determinant of 3 by 3 matrix. I, J, K, and then this is not commutative. You have to be careful. So A goes first, 3i, 1j minus 2k minus 4i, 0j, 8k. So how do you find a determinant of 3 by 3? It's very easy. You just copy the first two columns. Right. And then you do like the diagonal. So there, there, there. So times 0, 0. -2 times -4 is 8j. 8 times 1 times I is AI. All right. And then I do it like this. 8 times 3 times j, 24j, 0, -4 times 1 times -4k. So the answer will be the bottom minus the top. So you will have AI plus 8j, parentheses, minus the top, minus 4k, plus 24j. AI, there's no more i's, AI. 8j minus 24j minus 16j. Minus minus plus 4k. What can you notice? That the answer is a vector. So the cross product of vectors gives me a vector. The fundamental property is that this vector is perpendicular to both A and B. So the angle between the vector product and the other two vectors is always 90 degrees. All right? That is basically the cross product. Let's put it here. This is a cross product of vectors. And you're gonna use this in the second lab when we talk about the cure of vectors, right? And the cure and divergence are important because that's what we use to define things like Gauss's law and then later Ampere's law. All right. So that's the lab, right? It's important. So what do you have to do? You have to go to modules again, and you're gonna go and do the individual questions. You're gonna download this, and these are just exercises. For example, here you're gonna apply dot product, finding the force, like you have defined work in physics 1 like this. If I give you a force, I give you a displacement, you just have to find the work. Okay, this should be interpret the result physically. So I'm gonna change some of this. It's not good there. Find the unit vector. So, the net force. Yeah, that's right. The angle between the force and the path, you have to use a dot product. And then the directions of the net force, right? J, that's the angle theta. So you can find the direction of a vector. If you don't know, I'm gonna show you right now. The same here, and then here you have cross product. So let's do this is an example here with the work. So you have here, say a force. If you find some changes of that file, it's because I'm gonna go over and take a look. Some of them seem to be redundant, but if I give you a force, say in that one, they give you 6I plus AJ. You know why they give you this? Because it's very easy to find the angle. Newtons. To find the angle of this vector, you can just draw this here. 6I AJ. So the angle is this. It's another special triangle that you should know of. There's another special triangle. 8, 6, 10, 3, 4, 5. So tangent of theta, y over x, 4 over 3. So the angle is the tangent, the direction of that vector, 4 over 3. That will be about 53 degrees. All right, so that, and then the work is just a dot product. The angle, I just show you in the example of dot product how to find the angle. So that might be the only question I'm gonna give you there. This seems to be redundant. And then this one is the magnetic force. Here you have to use the magnetic force Q V cross V. So Q is just a particle Q, or it's an electron. So I'll tell you what the charge of the electron is. V and B. All right, so let's show you how to find this actually. All right. So I don't want you guys to get lost in that. The charge of the electron, one right here, Q is negative 1.60 times 10 to a negative 19 coulombs. You have the V and the B. Find the magnitude force acting on that. Okay, so you want to find the magnitude in IJK. So V is given in a vector form, 3I minus 1J plus 2K times 10 to the power of 5. And the vector QVB, the magnetic field, is always very weak, 5, 4, 6. So 5I plus 4J plus 6K Teslas, right? So to find this in vector form, you will have to use the cross product. All right, because the magnitude is easy. The magnitude will be as the magnitude of this times the magnitude of that times that. So in terms of vectors, the magnetic force is Q V cross V. So V cross V, you want to find this. That is found by doing the matrix. So I told you, I, J, K, and then you will put a V, 3, -1, 2, B, 5, 4, 6. You find the cross product, and then don't forget, you have 10 to the 5. All right, so you have to multiply whatever you get here, vector, times 10 to the 5, and then these are scalars. And that's the vector in IJK. All right, that's what you have to. I'm not gonna show it to you because that's part of the lab submission, but that's what you have to do. Now for the magnitude of the force, that I can show you. All right, so this is the vector form. For the magnitude, you do it like this. So basically, the magnetic force magnitude is the magnitude of Q V cross V, which at the end of the day is the magnitude of Q times the magnitude of V cross V. All right, so you will, the magnitude of Q is here. That will be just the positive. What about the magnitude of V? You have to find V cross V. That's why you are doing that in part A. You find V cross V and you do that. So let's suppose, or how to find the magnitude of a vector in 3 dimensions. Say vector V equals to 6I minus 3J plus 2K. How do you find the magnitude of V will be the square root of 6 squared minus plus, sorry, negative 3 squared plus 2 squared. 6 squared, so square root, that's 36 plus 9, 45 plus 4. 9, 36, 45 plus 1, 49. Sorry. Square root of 49. Oh, 7. There you are. So it works out. All right. So that's what you have to do. So you have vector, and then I'm gonna put like an extra credit this part. This is a rotational axis. Okay. So this one is a small proof that you guys are gonna do. In here, you're going to basically I give you all what you need. So this is X prime here. Y prime is what you have to find here. And let's just show you. All right, let's just show you how to do that. Rotational axis is an idea that you kind of use when you, for example, are working with inclined planes or when the axis have been rotated. So then you can have a better idea of the vectors acting on a given body. So pretty much is here, here, and then you have the rotated axis. Let's use our color. That, and you have that. So this is your x prime, y prime, and it has been rotated an angle of theta. So you have a point here. You have the x and y of the point, but you also have the, that's horrible. It's bad. There, right? So you have that y prime and the x prime. Now the x prime is given in the sheet in there for this point P. They ask you to find first to prove that x squared plus y squared equals to x prime squared plus y prime squared. Now they already tell you that x prime is let me show you that here, is x cosine minus y sine. That's already given in the sheet. So what about this proof? You need to find y prime. To find y prime, you're gonna use that triangle here. It's not very clear in there, but there's a triangle here. All right. Theta, 90 minus theta, this is 90. This is also 90. 90 minus theta, this is theta. So in the worksheet, they give you this is A, B, and they give you C. This is C. If that's C, y prime is C cosine theta. Now, C is y minus, this is A in the worksheet. This is A sine theta. So it's y minus A sine theta. So you replace that in here. Now, you also need A, but A is x over cosine theta. That's also in there, in the worksheet. So y prime is y minus A times cosine theta. Easy. Y cosine, y cosine. X cosine, cosine, minus x sine theta. There you have it. That's your y prime. That's your y prime. Okay, so then you can just do the square of this plus the square of this. Sine square plus cosine square is equal to 1. That's how you prove that they're both equal to each other. So it's not nice. It's probably going to be an extra credit, all right? Other than that, that's your first lab. Okay, so make sure that you submit those files. I try to give you a good amount of time. Make sure you show up for the introductory session I'm going to do. No mandatory, just to get to know each other on the first week of classes. All right. Have a good day, and I'll see you next time.